Here we're going to look at another number pairs and sequences problem. Now this time this will be a challenge problem. So does there exist an arithmetic sequence such that none of its terms are perfect squares? And if yes, provide at least one such sequence, and if no, then proves that there are no such arithmetic sequences. And usually the answer to these type of problems will be no, because usually the criteria of the question is usually too extreme to have at least one solution. However, you will see later that the answer to this question will be yes, and I will provide several sequences that satisfy this criteria. However, let's just recall the definition of an arithmetic sequence first. So an example of an arithmetic sequence is as so. So if 1, 4, 7, 10, 13, and so on. If you take the difference of two consecutive terms, that difference will be constant, or in other words, it will be the same every time. Now this difference, in this case 3, is usually called as the common difference. Further to note, the nth term of an arithmetic sequence will be the first term, or I would just denote that as a, plus n minus 1 times the common difference, let's just say d. This is the formula for the nth term of an arithmetic sequence. For this question, I'm going to use a trick involving modular arithmetic. So let's just observe some values for n squared congruent to modulo some number. So let's just say that this will be modulo 3. I'll claim that n squared will only be congruent to 0 or 1 modulo 3. So here's the proof. So I only need to do 3 cases actually right here. When n is congruent to 0 modulo 3, n squared will be congruent to 0. And when n is congruent to 1 mod 3, n squared will be just congruent to 1 mod 3. And when n is congruent to 2 mod 3, n squared will be congruent to 4, since 2 squared is 4, but it's also congruent to 1 mod 3. And you can see that the only possible values for n mod 3 will be 0 or 1, as claimed. Now the reason we're doing this trick is that notice that n squared cannot be congruent to 2 mod 3. So this is the weak spot right here. So if we can find a sequence such that all of its terms, when divided by 3, leaves a remainder of 2, then we're done. And in fact, we can find such sequence. And one such sequence is, let's say T of n will be the nth term of the sequence. This will be 3n plus 2. Now notice that when this formula is divided by 3, it leaves a remainder of 2. Or in other words, it is congruent to 2 modulo 3, as desired. And let me just write the first few terms of the sequence. So this will be, let's see, 5, and then we have 8, 11, 14, 17, 20, and so on. Another sequence is that T of n could be equal to 3n plus 5, or let's say 6n plus 2. That also works. And there are infinitely many sequences that satisfies this, as long as when each of these terms are divided by 3, it leaves a remainder of 2. So the answer to this question is yes, which ends this video.